Okay, so we're going to be needing to look at this. We're trying to find the angle between two vectors. Okay, so this is the kind of thing you got to kind of take a step back, and this is the frustrating thing in statics is I can't just work one problem for you and be like, all these problems are going to be like this. You know, you've got to be able to go back in time, not back in time, but you got to kind of in your brain figure out, okay, it's all about problem solving. It doesn't matter that you can look up the answer in the book and be like, oh, I understand how they got that. The point is to go through the process. So if you're just watching these videos without trying the problems on your own, you're really putting yourself at a disadvantage. Okay, you need to be thinking. This is all about productive frustration. So pretend you've done all that. So to find the angle between two things, we remember that the dot product of one thing with the other thing is F1, F2 cosine theta. So if I can find F1, if I can find F2, then I'd be able to find the angle between them. Looking at these, I'm not exactly sure which one I want to start with. I might as well start with F1. Okay, so F1. I'm going to do this where I pretend that this is flower axis. So I have essentially over here, I have flower axis going this way, and I have Z axis going up and down. Okay, so the reason I've drawn it like that is because this line right here, that you can't see, this line right here is in the Z flower axis. Okay, this just helps me picture it sometimes. Again, I don't picture things as well as I wish I did, and so I've got a lot of tricks to kind of reframe what's going on. And Z and flower are perpendicular, so if I draw, you know, myself, hold on, let me draw this a little bit. Come back, flower. I meant to draw this a little bit longer. If I was going to draw this up like this would be perpendicular. That's a weird to put it on that side. Perpendicular. So I've got my 30 degrees. This 30 here is the 30 between flower and Z. Okay, so that's this 30 degrees here. And the length of that F1 vector is 30. Okay, because it gives me the magnitude. So that's 30. I've got a 1, 2 square root of 3 situation. So this is 15, and this is 15 square root of 3. Okay, so now if I look at it from the top, so the flower distance is 15 square root of 3. The only real value I'm going to use is the Z from here. So that's going to be, that 15 is going to be in my final answer. Okay, but now I've got to kind of picture what's going on here, X and Y. So I've got this is flower. You can't see my flower. Now the length along the flower is this 15 square root of 3. Now I put it in quotes. It's not that it's not 15 square root of 3. It's just not going to show up in our final answer anywhere. But the length of that right here is 15 square root of 3. And that's where that comes from. 15 square root of 3 along flower axis. Okay. And then I can go ahead and do this, and it's going to be perpendicular right here. Okay. So I've got a 30 degrees that's between Y and flower. So that means I've got 30 degrees between Y and flower. All right, so I can do the 1, 2 square root of 3 thing again. So what is a 7.5 square root of 3? Because it's half of that. And I guess it would be 7.5 square root of 3 times square root of 3. Yeah, 1, 2 square root of 3. So I guess that would just be 7.5 times 3, which I should know what that is off the top of my head, but it's just not happening. 7.5 times 3 is 22.5. Okay. So I've got my X component is 7.5 square root of 3, and it is in the positive direction. I've got the Y component, running out of colors. This Y component is the 22.5, and it's also in the positive direction. This is the hardest part of these problems, but it's such a critical skill. So please don't do the thing where you're waiting of like, I can't wait until we're done with all this stuff so we can get back to statics. This is what statics is, okay? This is absolutely what statics is. And then we've got our z component right here, which is the 15. So that is my position vector, or not my position vector, that is my F1 vector. Awesome. Believe it or not, I feel like in some ways that was the easier one. I don't know. All y'all, go away. Go away more. Go away lots. Meow. All right, there's part of the square root sign that's now lonely. Okay, now I'm going to focus on F2. And this is kind of annoying because it only gave me a 60 and a 60 and it didn't give me the other one. So this is an alpha, beta, gamma thing. Arg. Okay, so alpha is the one that comes off of the... Oh, that theta has nothing to do with alpha, beta, gamma. That's the angle that we're looking for. Alpha is the number that comes off the x, which that's the one they haven't given us. See this? This is alpha, which they have not given us. Alpha is, I don't know. Beta is the number coming off the y, which is 60. And the gamma is a number coming off the z, which is also 60. And at this point you go, I can't work this problem because they didn't give me alpha. And then you're like, oh, but there was that one thing that we were told we were supposed to remember, and then I promptly forgot it. Yeah, that thing. So it's the thing where we go that the cosine squared of alpha plus the cosine squared of beta plus the cosine squared of gamma is equal to 1. Yay! Cosine squared of all of these, so this is cosine squared of alpha. Cosine of 60 is just 1/2, right? And the cosine of 60 is still just 1/2. So cosine squared, I guess I could have done this on a computer. A half minus a fourth minus, sorry, 1 minus a fourth minus a fourth is just going to be a half again. No. Yes? Why is this so terrifying? All right. Why do I feel like I'm doing something stupid? Let's try this again. 1 minus 0.5 squared minus 0.5 squared. 0.5. Okay, good. Oh, I need to take the square root of it. That's what's going on. All right, so square root of 2 over 2, basically. So cosine of alpha is plus or minus. Now, this is the important part. Square root of 2 over 2. Okay. This plus or minus is the most important part of this problem. Whoa. So important I erased it. It's the most important part of this problem because that means that there's like lots and lots of answers. So remember with cosine, so if I take the inverse cosine of this, I shouldn't necessarily have to, but I can. So if I inverse cosine this thingy, and I'm in degrees, I get 45. So remember that that's 45 here to get positive cosine, or it's 45 here to get positive cosine. But it's also 45 here to get a negative cosine, or a 45 here to get a negative cosine. And what makes this problem difficult is that my answer for alpha can either be 45, what's 180 minus 45? 135, or 180 plus 45, so that's 225, or 335, right? Wait, 360 minus 45, or 315. Any of those could be correct for alpha based on this equation here. And the only way to know which one we're doing is to look at the picture. So looking at the picture, does this angle look like 45, 135, 225, or 3, whatever I just said, 315? Okay, so hopefully you look at it and go, well, it looks like more than 90, but less than 180, so it must be the 135, and that's exactly how you figure that out. Okay, so once we get the alpha, that is 135, now we can actually move on with this problem. But the first problem we had to solve was what this stupid alpha was. So now you can go away, and I'm done with that guy. Okay, I feel like that's something Joe Pesci says, and I don't know what it is that he says that in. No idea. Oh yeah, it's from My Cousin Vinny. Okay, that was fun. Okay, so now once we know that alpha is equal to, what did we say, 135, now we're in business, okay? Because that means that theoretically, I love saying that, all we have to do now is we just do the value times cosine alpha, that's the I hat, cosine beta is the j hat, and cosine gamma is the hat, the j hat. So that's going to be the 25 cosine 135, 25 cosine 60, and 25 cosine 60. So that's what I'm looking at there. So I've got 25, oops, yeah, that's right, cosine 135, 25 cosine 60, which I guess I could have written as 1/2, but I'm committed now, 20 cosine 60. And you're probably thinking, well, don't I need a negative sign because this is in the negative blah, blah, blah. But see that cosine 135 right there? It takes care of the negative sign. So you're actually good to go. So these turn out to be negative 17.7, 12, and 12.5. So those are those values there. Okay. Deep breath. Now that we have this, so basically what we needed to do is we had to go through these problems and we had to break them all down. This is a wonderful problem to come back and work again like in an hour, and then to work again like tomorrow, and then to work again like a half a week from now. Because if you can do this problem, you've basically mastered the fundamentals of the most annoying parts of these problems. And this is like I've been saying, something you really, 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 really want to get just phenomenally good at. Okay, so let's take this information here. Okay, come here. This information here. Not really sure what it's doing. All kinds of weird. I was trying to move this out of the way. Watch me fail to do basic things. Okay, so I've got f1.f2. Dot product. The f1, which is way up here somewhere. Maybe. Right there? No, I didn't even ever put it in. Oh well, I guess I'm going to put it in now. No, come back. Yeah, I like to have these written out just because it helps me make sure that I don't have something dumb. 7.5 square root of 2. See, that doesn't sound right. Was it supposed to be square root of 3? And nobody told me? It was 7.5 square root of 3. I just wrote 2. How come y'all didn't say anything? 7.5 square root of 3. Okay, 7.5 square root of 3, comma 22.5, comma 15. Okay, now I'm going to dot product these. Okay, batamp and batamp. And I'll get a constant, not a constant. I'm getting a big giant number, which is maybe not what I wanted. Did I drop a negative sign also? You know, I shouldn't be allowed to function. That 15 is negative. Okay, I'll have to make that as a note in a minute. Oh, man. This is what happens when I make too many videos at once. All craziness happens. Okay. So apparently you should also do this problem multiple times before you try to do it in public. Ah! Okay. So now let's try this again. The dot product of this number with itself. All right, negative 136, which actually is what matches my piece of paper. Negative 136. Now, over here on the other side, I always want to go in and then like do the square root of the dot product of the number with itself. But then I remember that I actually know what the stupid magnitudes are because that was given to me like at the beginning of the problem. The magnitudes of those are 30 and 25. So I always do more work than I should have had to do. It's just a thing. So if you did that too, don't worry. It's a thing. Divided by 30 times 25. So we got this negative 1.81. Or 0.181, not 1.81. That would be a super weird cosine. So inverse cosine of that thingy, okay, is 100. And the nice thing about taking this inverse cosine, so it's either going to be I guess this 100 or this 100. So looking at it again, I can see that it's smaller than 180. So it's this 100 and not the whatever the equivalent of that would have been, 300 or 260. So it's that 100. So theta here is going to be 100 degrees. So this problem is fun because we've got to remember a whole lot of things, but I'm really, really glad that y'all kind of sat through this because I promise this is the kind of thing that's going to be like kind of driving you crazy. But I promise that one day you'll get to a point where you're like, oh, what a cute little problem. Okay, so you got this.